going to be chapter 4, part 2, chapter 5, I guess this will be. We're going to be talking about how can we take those quantitative graphs that we've been looking at and been creating, how can we describe them? What is it that we can go about saying about numerical data? When we looked at categorical data, we didn't have a whole lot to talk about. It was kind of like the most of the least in terms of percentages, what took up more of the pie chart, what took up more of the pieces on the segmented bar charts, which bar was taller or shortest. When we have numbers, we're going to have a lot more to deal with, right? We can talk about statistics, we can talk about means, and medians, modes, we're talking about standard deviations, IQRs. All of these things are going to play a part in how we look at describing the relationships between data in just a single distribution, or how might it compare to different distributions. So those are some of the things we're going to talk about. Essentially, if I ask you to describe the distribution, right, those are keywords that I need to think: shape, center, and spread, right? We're going to talk about that. You see it on the screen: shape, center, and spread. Essentially, shape is pretty much what you think of. How does the graph look? We have a few words to describe those particular shapes. Center is dealing with means, medians, and modes. Which one should I use? Is there a better one in others? For the most part, yeah, there is a good, clear definition of which one should I use. In some cases, it won't matter because they're similar. And spread is going to talk about how spread out are the data compared to each other. We talk about IQR, range, and standard deviation in that example. So let's kind of get into it. Here I'm looking at a graph, and this is a histogram that has a tail off to the right side. Now, a lot of people want to say this graph is skewed left, but that's wrong. Where does the tail go? Look at where the tail is. You can see the tail here goes off to the right side. That's clearly skewed to the right, right? The majority of the data is not what the skewness is. It's where does the tail go off from. And so in this case, you're looking at what we call a skewed right graph. We're going to talk about shape to start with. So let's kind of get back into that. Right? You saw a minute ago skewed right. I'm just going to kind of run through these. You can pause the video if you want to kind of draw a sketch and label it. I would definitely take time to do that. Here we have a graph that is mostly symmetrical. And when we talk about things like this, I'm not going to be talking about perfection. If I say symmetric, you can see in the graph here that this is not perfectly symmetrical, and I don't expect it to be. This is statistics, and for the most part, stats really don't work in a perfect world, right? We're describing things that we see and that happen for the most part. And this is symmetric. Okay, the next one we're going to look at is considered to be skewed left. It's got the tail off to the left side. You can see that really clear here. Here again, it doesn't have to be like a definitive answer. It can say it's slightly skewed left. It's really heavily skewed left, right? Those are words that you can use to qualify exactly how skewed it is. In this case, this would be a skewed left graph. I wouldn't say it's very skewed or it's just slightly skewed. It's kind of just obviously skewed. The other one is what we would call a uniform distribution. Here you've got a graph that's mostly kind of straight across. It doesn't have to be perfectly level, but for the most part, the responses for each variable, each bar, has about the same height all the way across the screen. Okay, so that's shape, right? That's probably the easiest thing to come by. Be careful about the skewedness. That's when people tend to get mixed up on, so make sure you get that down right. The next part is center. Center and spread kind of go together, so we're going to kind of talk about the relationships there. When I'm looking at center, I want to talk about where does the majority of the graph fall. And we can talk about what do you mean center, right? Am I talking about average? Am I talking about the 50%, right? What number marks 50% of the data here and 50% of the data there? Well, that's the median. Or maybe we just wanted to talk about the one that occurred the most, like the graph you see here. I can see here that it is very obvious that 2 hours is the median value for the number of hours spent watching TV on an average day. And I think probably in this case, if I were to give the mean or the median, it's going to be dragged out. The mean is definitely sensitive to outliers. When you have a skewed distribution or you have really high outliers, giving the mean is a very inappropriate response. The median value is what we consider resistant. It does not get affected by skewedness. Its value is position. I want to get the middle number, right? Doesn't matter how far down the line that last number is, it's still the middle. But if I'm trying to find averages, think about how if you have grades and all of your grades are somewhere between 80 and 90, maybe you have a couple of 90s and a couple of 70s, right? But then you make that 25 on that test, what happens to your average? Tanks, like bad, right? So the farther away that number is, the worse it's going to pull down your mean value. But your median, it goes from whatever it was originally, and you throw another number down here, it just drops to one number down. Or maybe it's averaging between those two numbers if it's an even value, right? So median values are a good place to talk about, especially where you have skewed distributions. Another example would be, let's say, house prices. If you're going in to buy a neighborhood, and most of the houses are pretty much the same, but you've got that one house that's been in the neighborhood forever, way in the back, that's gigantic, and it's on the lake and everything else, right? It's worth several $1,000,000, but every other house is worth a few $100,000. When you say the average price of a house, it's going to be way above what the most prices are. That's why you typically see, if you read house prices and things like that, you're going to see the median value, because it's going to give you a much more representative of what most of the houses are priced at. So be careful when you have skewed distributions. Choosing the median is much better than the mean. Now, we like the mean. We like how the mean weights everything the same. So when you have a symmetric distribution, that's when I want to use the mean for my center. The mode, when you have multiple centers, like maybe if it's multimodal, maybe bimodal or something like that. Let's say if you're looking at the height of a group of people, you might have two groups. Men and women have a different average height, and so you may have two different averages. And so in that case, the mode might be a better place to find your center. That's the one that's used the least often, so be careful with which center you choose. Spread. There's two easy ways of finding spread, and that's range. That's the easiest of all. A lot of the times we're left out with no data, but we can see the graph, and we're left to choosing range, which is just the maximum value minus the minimum value. The interquartile range is the IQR. Now, we're looking at quartiles. In other words, 25% and 75% is Q3 and Q1, right? And so if I were to put the numbers in order, if I had 100 numbers, the 25th number would be Q1. The median value, which is the 50th percentile, that's going to be the 50th number. The 75th number in the list is going to be your Q3 or 75th percentile. And then Q4 is 100%, or the maximum number in that list. So those are what quartiles are. They're the quarters, and you break them up into equal percentages of numbers. So if you had 100 people in a line in order of, let's say, height, then I could mark off who's the 25th number. That person would be the 25th percentile. Whatever their height is, says that 25% of that population is as tall as I am or shorter than me. A lot of times you see quartiles and percentiles used in standardized testing. If you made a certain score on the SAT, then they would tell you you scored in the 95th percentile, which means your score at the time you took it was 95% of the people that took it would have scored what you did or less than you did. So a higher percentile means you did better when compared to the people in your class. They could all failed it. But if you scored in the 95th percentile, you just scored better than or equal to 95% of the other people there, right? The interquartile range is the measurement of the middle 50%, right? You've got Q1 and Q3 here. If I subtract those values, it tells me how far is it between Q3 and Q1, or Q1 and Q3. Standard deviation is a lot more involved, and I'm not going to kind of go through that with you by hand, but what we can do it this way. I'm going to put a set of data up, and I'm going to kind of walk you through using your calculators. So grab your calculators real quick. What you're going to do is you see the price for your laptop. Now, this is 10 years ago. You've got these prices. What we want to do is we want to find some of the statistics based on this information, right? Specifically, we want to talk about shape. Well, not shape, but we want to talk about the mean and the standard deviation. I'll show you a few other things too. So right now, if you press Stat and then Enter, it's going to bring up your list. We're going to do a lot of things with our lists. Hopefully you've used this before, but in case you haven't, what I'd like for you to do is take a minute, pause the video, and enter each of these values in this order. You don't have to do any kind of special ordering, and put those into your L1. You pause the video and then come back when you're done, pause it when you're done. Now that you've got all the prices in, we're going to compute some of those one variable statistics, right? You have one variable, which is the price of the laptop. If you'll press Stat and press the right arrow key, you're going to go up to the top where it says Calc or Calculate. And the first thing you see there is one var stats. If you'll press Enter, it's going to bring up another menu. Hopefully there it's got your list, and that says L1. There's a frequency list. You can leave that blank for now, and then calculate. I want to go ahead and make sure it says L1 there. If it's not, to find your lists in a quick way, you press second and then go down to 1 through 6 on your keypad. If you look at there in blue, you'll see the L1, L2, L3, L4, L5, and L6. So anytime I want to insert those lists in, the quick and easy way is to press second and then one of those buttons. But you want to use L1. Hopefully, if you used a different list, maybe you used L2 instead, make sure that you use the list that you put your numbers into. Once you do that, hit calculate, and you're going to get a bunch of stuff. You're going to get the mean. You're going to get X bar, so maybe you want to write some of these down. X bar is what we consider the average. That's the first thing on that list. Scroll down or just look down. What you're looking for next is the S with an X, like a subscript, S sub X. This is our sample standard deviation. Just above that, or maybe it's below it, I can't remember, there's a little O with a tail on it. That's lowercase sigma. That's population standard deviation. Now, I know that these laptops where you just typed in, that's not every laptop in existence, right? So this is definitely a small sample from a bigger population. So we're going to be using S as the sample standard deviation. That's a big deal, right? Don't confuse those two because they're definitely different. There's a little bit of a difference in the formula, right? So that's my standard deviation. If I scroll down, you're going to see a few other things. You're going to see N, which is the sample size. That should be 10. And then I'm going to see the minimum value. I'm going to see Q1. I'm going to see the median value, Q3, and the max. This is called our 5-number summary. Okay? And so at that point, what I'd like to do is kind of like take this next. And if I could, at that point, I could figure out what am I going to do to talk about what's the average price or the median price. I've got that. If I wanted to make a graph, I can do that as well. We'll do that at another time. Which would be a better measure of center here. Now, you can look at this without doing a whole lot of things, and you can see that the MacBook Pro here is $2,000, and that is significantly higher than most of the other ones. You've got a couple up here around 1,500, but then you've got quite a few under 1,000. So it looks like this graph is going to be definitely skewed to the higher values, or it's going to be skewed to the right. So the median number is going to be a much better measure of what most laptops are going to cost. If I were to give the average, it's going to pull it way up higher, and I'm thinking, wow, the average laptop is relatively expensive. In this case, well, all of these are expensive, but compared to the rest of them. And so the median value would definitely be a much better measure of center in this example. Okay. The next graph is called the box plot. Now, you just found the 5-number summary for those laptops, right? It's minimum, Q1, median, Q3, and max. Okay, this is one of the nicest, quickest, easiest graphs to make in terms of if I have a calculator. If I don't, I've got to figure out the median values. You have to put them all in order. Then you got to find which number is going to be the 25th percentile, right? So if I had, let's say, 20 numbers, I'd do 0.25 times 20. It would say, oh, what's the quartile, right? So number 5 would be the first quartile, then 10, then 15, then 20, right? So that would tell me how to find it if I didn't have the calculator. Put them in order and go from there. Here's my 5-number summary. I'm going to go ahead and make a box plot. First thing you want to do with the box plot is you want to make a number line. Do not make the box plot first and then think, oh, well, I'm just going to stick my number line underneath it. Those numbers need to be equally spaced out relative to each other. So if there's a big difference, if there's a big space in between them, then I need that space to be relatively the same size space for all the way across the board. A lot of times I see students make these graphs and they're really small. Or not small, but they don't pay attention to the intervals, right? So make your number line, put those 5 numbers down like you see here, and then create your little boxes, right? So the Q1 and Q3 are the ends of the box. The median is always going to be that one in the middle, which also could be one of the edges of the box if you have enough numbers to repeat. And then here's my box plot. Sometimes, kind of for a future note, you do have outliers. In a box plot with outliers, we call it a modified box plot. In that case, I would put a dot for an outlier and drop that top whisker back to the next number in the list to indicate I do have outliers in this case. Okay, we'll pick this up next time.